Hi everyone, I am Pratyush Pandey and welcome to Educational Series. Today we will do our universe topic with many topics inside it in the series Space Series. So let's start. So these are the topics we'll discuss today: Big Bang Theory, time dilation, gravitational time dilation, black holes, effects of space on humans, sky gazing, and night sky. So let's start. Now, Big Bang is how, as I have already told you, is how astronomers think about the space or the universe started. Its origin, it's started, and everything which is in the universe was somewhat a singular matter known as singularity. You can see in this diagram, you can see the afterglows. These are dark ages where these were thought to be a size of a pea, but much heavier than a pea. These were thought when this singularity exploded, then our universe started. This is according to the Big Bang theory. Then you can see how galaxies and planets developed as the universe expanded and cooled down. So it took 13.7 billion years. It happened 13.7 billion years earlier from our this today. So as we know, Big Bang theory is one of the expected theory, and we don't have any much proof about this theory. Here is time dilation. Now we'll go to the board for time dilation. Now let's see time dilation. Before understanding time dilation, now let's see how speed matters according to our perspective. Let's suppose there are some trees along the roadside. Which are moving, the speed is 0 meters per second, which are they are not moving. I'll magnify it. 0 meters per second. Now there is a red car which is moving at 5 meters per second, and the blue car, another car on the along the road, is moving at 10 meters per second. So now let's see their perspective. An observer which will stand at the tree he will see the same thing, that the trees are moving at 0 meter per second. Red car, at the speed of red car is 5 meter per second, while the speed of blue car is 10 meter per second. Now let's see when an observer is in the red car. The observer in the red car will see that the trees are moving back at 5 meters per second. Their speed is 5 meter per second, and the blue car now is moving at 5 meter per second ahead of it. Now the red car is actually moving at 5 meter per second. So the observer who thinks that he is stationary because now it's moving at a constant speed of 5 meter per second. So what is 10 minus 5? It's 5 meters. So he will see that the blue car is moving at 5 meters per second. Now if the observer is in the blue car, then he will see that the trees are going back at 10 meters per second, because that's its speed. The red car is moving back at 5 meters per second. Now you see here that how speed can change according to our perspectives. Now let's see time dilation. According to how time dilation actually occurs, which matters the speed. Let's see the light clock. So in a light clock, there are two mirrors and a counter. When the surface is closed from all sides, and a light beam is thrown in the structure. So the light beams bounces between the two structures. It bounces up and down between the two mirrors. So now let's do some mathematical calculation Let's suppose the speed of light in actual is around 3 lakh kilometers per second, but for simplification we'll see only 6 meters per second. Speed of light, and we have to take out the time. So here distance is suppose 12 meters. Now the time will be 2 meters per second. 2 seconds, sorry. So the 2 seconds means a light ray takes 2 seconds to bounce from one mirror to another mirror. It goes up and down. It takes 2 seconds to go from one mirror to another mirror and bounce back. Now if this time clock is placed in a rocket which is moving at the speed of light. Now the speed of light is because it's very huge and very fast. So now the light has to go an extra distance. Now how you will see how it has to go an extra distance. Now the mirrors or the structure is moving with the rocket. So the light to cope with the movement with the rock, to go with the rocket, the light has to cover an extra distance. An extra distance to move. That distance adds up to the distance. That distance which we saw adds up to the distance here. Now let's give that the time here, the speed of light does not change. It's 6 meters per second. And that the same now the distance is multiplied because the distance has been higher or enlarged. So it's 24 meters per second this time. 24 meters this time. The time will be 4 seconds. So the time is 4 seconds as I have told you. Now what does it mean? That for the people inside the rocket, the time will be only 2 seconds. But for the people outside the rocket, the time will be 4 seconds. Time dilation. So this is just the dilation of time. But there's the dilation of time because of the motion which is nearly the speed of light. So the motion, the speed, as the motion which causes the dilation of time or the slow time to pass slower for the people in the vehicle which is moving at the speed of light. This, when the time slows, this is known as time dilation or the time slow. Now let's see this in the PPT. Now let's see time dilation. As I have already told you, time dilation is a difference of elapsed time as measured by two clocks due to a relative velocity between them or their speeds. The difference in the speed, difference in gravitational potential difference or potential between their locations. I have already told you that near a black hole, as we have done in the gravitational potential time dilation, in the gravitational time dilation. After compensating for various singular delays due to the changing distance between an observer and a moving clock, as the speed you can see here, if the light clock placed on rocket and light clock placed on earth, so as the earth is somewhat stationary, so the light has to cover a distance from this here to here. But in a moving rocket with the speed of light, the light has to cover an extra distance, which causes time to slow down. Because time to slow down in two cases, such as when it's the speed matters or the time clock or time is in near a gravitationally bent area, which we have learned. Now let's further progress with our chapter. Now let's see gravitational time dilation. Now an object like Earth or any planet, any celestial body, bends or distorts the space-time. So the space-time which was earlier like that, it bends the space-time. Any object bends the space-time. Now when light passes, now suppose this is Earth, and if light has to pass from one point A to point B, then instead of taking a straight path, when light passes through the bent universe, the light too has to bend to reach from point A to point B. So when the distance has now we know that the light takes the shortest path. Now what happens? Now let's see that this gravitational time dilation is known as time dilation because, as I have already told you, light from point A to point B takes a longer path or takes more time to reach its destination. So the time, because the speed of light cannot change, so the time has to slow, or the time is affected or slowed in a when time is affected by gravity or in a gravitational bent universe. Now let's see how can time be slowed by gravitational time dilation. So suppose that the universe is not bent at this place and light travels from point A to point B. Now the formula is speed is equals to distance by time. Now we know the speed. The speed of light is around 3 lakh kilometers per second, but here we will take 2 meters per second. So the speed will be 2 meters per second, and the distance, suppose it's 6 meters. So the time will be 4 seconds. The time will be 4 seconds. The time for light to go from point A to point B will be 4 seconds. Now let's see the case of a gravitational bent area. Now the distance from point A to point B is increased because of the gravitation. The light has to move in the curved path. So now suppose the speed and distance, known as distance, is 12 meters. So let's see what the same rule. Speed is equal to distance by time. Speed of light does not change in any area according to physics. Area of universe according to physics will be speed 2 meters per second, and distance is now 12 meters. So now the time will be 6 seconds. So now you see that there is change in the time in the gravitational bent area. So the people around a gravitational bent area, the time to them will be only 4 seconds. But to the people outside the gravitational bent area, you can see the time has slowed down. They need to cover. The time is 4 seconds. Now the distance is 12 meters. So the time will be 6 seconds. Now you see that the time has slowed down when a person comes near a gravitational place where the universe is bent and gravity is included or gravity is affected. The universe is not typically bent. That is known as distortion of universe, which occurs, I have already told you, is important for it occurs when a heavy object occurs force, so that loop occurs which causes gravity. Now let's see. Now it's not mentioned, but I will tell you a fun fact that how planets revolve around Earth or anything which they revolve. So now suppose a planet, as I have told you, anything bend the surface. So it has also bent, but that bend is smaller than the universe bent by the sun. That's why the Earth revolves around the sun. Now you will say that why don't Earth fall into the sun? This is because that Earth too has bent space-time, so it will revolve and revolve. Because of centrifugal and centripetal forces, it will revolve around the sun. And same case with all the planets and binary stars and anything which resolves a bigger object. Now let's see what is about a black hole. In a black hole warps time too much. So that warp time if the time is warped, now the time will appear more slowly near a black hole, because now if a time can be slowed in near minus in near the slightest gravitation also to nanoseconds. So when an object has bent the space-time so much, then the time slows down and even stops as we go near a black hole. Now let's see about time dilation, which I have already studied, and gravitational time dilation on the PPT. Now let's see the gravitational time dilation on both. So as I have already told you, this effect measures the amount of time that has elapsed between the two events observed at different time distance from gravitational mass. In other words, time runs slower where gravity is stronger, and this is because gravity curves space-time. Now don't see that. Now see this as now you can see that the Earth has bent the space-time. The light which moves from here has to take a longer way to go from point A to point B. Point A to point B takes a longer time. So now the speed of light cannot change. So the time slows there where a gravity is larger. As the time slows, the persons or the people around the gravity bent area will have lower time than another in where the place is not bent because of gravity. Now in a black hole, as I have already told you, the gravity is bent so much that the light has to take a long way to go. The time slows down and absolutely stops as we go and down a black hole, inside a black hole. This because as the time air just slows down for light to travel in the same place, so the person living on another side will be, if they 65 years for a person living on Earth, that will only 5 years for the person living near a black hole, because the time moves slower here. I have already told you, because as of the distance the light has traveled, the time slows down. So just same, the time is more distance, the time has slowed. Now black holes. Now we have discussed about black holes only. Now let's see what is a black hole. Black hole is a region of space-time where gravity is so strong that nothing, no particles, not even electromagnetic radiation such as light can escape from it. Now as we know that the bends black hole or any object bends space-time. So because of that bent space-time, you can do this activity also. That and when the space-time is bent, the heavy object bends the space-time more. Then the lighter object goes in circles around the planet or get attracted by the body. That is gravity. The more the mass, the more the space-time is bent, and the more the gravity an object has. The theory of general relativity. Theory of general relativity predicts that a sufficient compact mass can deform space-time to form a black hole. And if there is sufficient mass, then the space-time will distort that much that it will cause a black hole, from which even light cannot escape. Black holes. To distance observer, clocks near a black hole would have appear to tick more slowly than those further from the black hole. Due to this, known as gravitational time dilation, an object falling into a black hole appears to slow as it approaches the event horizon. Event horizon is the last point in black hole from where we cannot escape from, taking an infinite time to reach it. Now you can see here, when there is no gravity bend, then time taken to go from point A to point B is less. But when the gravity bends the space-time, the light has to take a longer way to move from one point to another point the same distance. Now the speed of light cannot change, so the time slows down near a gravity, near a black hole or something with gravity. Now if the object if there is less gravity, it can happen in nanoseconds. The time can slow in nanoseconds. But when near a black hole with a lot of gravity, then the time slows down and we can feel or see it. And we can see that the time is taking slowly to observer who can, distant observer can see. Yes, now we have come up on another topic, effects of space on human body. Now let's see what is the effect of space on human body. So effect of space are many spaces such as in the internal body and outside body. Our body gets weak and we get fit, and also it affects our dream. So now let's see. It can damage our central nervous system with both acute and later consequences. Manifests itself as altered cognitive function. Blah 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 blah. This is the definition of how it affects on human body. This is we have given in the PPT, but just I want to say that it causes fatigue, sickness, and acute effects and consequences on a human body such as weakness or bone and muscle loss. Here is the diagram. So you can see here exposure to high energy, because in space there is a lot of radiation. So exposure to high energy radiation increases the risk of neurodegenerative disease. It affects the brain. Eye abnormalities may rise due to UV exposure and increased intracranial pressure. Now the pressure on our eyes is increased. Actually, increase the phone brightness, then the pressure on our eyes increases. That's same when there is lot of light and UV radiation in space. Due to microgravity means no gravity. Distribution of fluids from the upper body results in puffy face appearance. Now the fluids in the body got collected in our face, which gives us a puffy face look. That heart stroke volume decreases as carnivorous cooler system adapts to microgravity. Red blood cells number also decreases. This means that the pressure which the blood pumps, now if you are weightless, then the heart has to do less pressure to move, because we are laden down, the fluids can flow. That's why the number of red cells and the pressure decreases. On the number of times the heart beats decreases. Molecular adaptation to microgravity leads to the loss of muscle mass and bone density. The muscle mass and the bone density, if we don't exercise in space, then because the muscles are not in use, so the muscles will scrap away or will be of new use. Then they will get damaged easily. So the astronauts which go in the space have to exercise every day. Blood plasma volume and stress spaceflight and liquid redistribution are some of the causes which have happened to human body when exposure to space. Even if an astronaut in the rocket too, these circumstances can happen when they go UV radiation. They can come in contact with UV radiation when they go outside the space on spaceworks. Now let's see sky gazing. This is an amazing photo. Now let's see what is sky gazing. Sky gazing, or more literally, is just gazing at the sky to look at the natural beauty of space. Also here is same for amateur astronomy. It's done mostly with naked eye or basic aids, as it is written here. Yeah, night sky. The term night sky, usually associated with the astronomy from Earth, refers to the scene viewed at the night time from Earth. Many amateur astronomers or early people used to see the night sky and explore about the stars and their position and how they move. As here it is written, they observe the stars, planets, which are visible in a clear sky between sunset and sunrise, where the sunlight does not obstruct the view, and when the sun is below the horizon. Thanks for watching the video. This was all in the video about space. Some topics, mainly discussed topics or the beautiful things in space. If you want this PPT, the PPT is in the description box below. If you like my video, please like, share, subscribe my channel. And also I have made a space series which you would have seen in the starting of the PPT. In the space series I launch videos recording to space from class 6 to 12, which is out from the syllabus. But this space videos will give you a lot of information about space. Thank you.